who were very active in the modular units, test panels, and other.
The hardware people I knew only, in passing, and it was only outside of the programming people directly. The people involved with logical design were the only ones I really knew at all well, and the group leaders that we sat in on weekly meetings. And most of them have stayed on in Lincoln or MITRE.
I got to know a bunch of the hardware types through a driving pool. Hugh Boyd.
Oh, yes.
Was, I think the guy that originally, he moved from BARDA over to Instrumentation Lab as our executive officer for a few years. But there was Norm Taylor and Bob Everett and Steve Dodd. All of us lived, more or less contiguously.
I saw both Steve and Hugh Boyd at the Deck Museum when Forrester spoke.
Yeah. That was a nice evening.
Yes, it was.
Yeah.
How much of a connection was there between, because I had gone by that time, between Whirlwind and Project Mac?
My impression always was that it was a remote
I know Corby
connection.
is a connection, but it was pretty much a new effort.
Right.
I think so.
So I remember it was being discussed when I left MIT.
And how about, is it Dave Brown who went to the University of California?
Dave Huffman? Or?
Brown, I think.
There was a Dave. I guess he went there. I lost track of him.
Fairly early he left. There's a question that I've had on my mind ever since I knew that we were going to have this session. Let me put it to you. I had a very interesting visit with Phil Morse. Oh, golly, 3 or 4 years ago, maybe not quite that long. But he was telling me stories about Whirlwind's foot dragging on high-level languages and how a tradition of programming at assembly language level or even lower had grown up around Whirlwind, and they just weren't about to sacrifice any of its precious capacity to.
Well, Sheldon Best was not sacrificed, but
Contributed was the
contributed
Yes, right.
to the higher level language effort.
Yeah, but I bet it was on the assembly language level.
No? Oh, well, he was writing assembly language.
Well, they had such a good assembler. They didn't need it.
That's what Phil would have said.
Well, to this day, I find it easier to program in assembler language than I do in higher level languages, because the kind of mistakes you make are orthogonal. If in a higher level language, you have to learn syntax rules, and you have to have them right. And the syntax rules are much more complicated than they were for assembler language, where the syntax was relatively simple. On the other hand, it was easier to make logical errors in the assembler language, and of course the high-level language is supposed to protect you from this. But I didn't make many logical errors, but I made a whole lot of syntax errors. And so I think if you like logic and you're good at logic, assembler language is the thing to use, particularly if you're terrible at syntax. And that was exactly my position. When I first saw a higher-level language and tried to use it, I'd forget a period there, and I'd put a comma in the wrong place, and I'd spell some control word incorrectly, and I thought, oh, why in the name of heaven does it require me to put all the periods in the right place? And assembler language, I never had any of that problem, because the syntax was just delightfully simple, and you had to carry some logical intricacies in your head. But I found that rather enjoyable rather than painstaking.
I can echo you in spades. I've gone through a 2-year period of coping with TRS-80 BASIC. And it isn't that I mind programming in a higher level language, but there's an added dimension to it, which is the quality of the diagnostics. That
it's minimal.
Everything is a syntax error.
Just before coming here, I stayed up until midnight last night trying to find an error in a high-level language program. And it was the type of error for which there was no diagnostic. I mean, there was nothing you could do to that program except study it to find out
Well, I have made
that would never happen in
an observation, reasoning after the fact, that in fact non-printing characters can get into your
Exactly.
line of code, and you never know they are there.
And I suspect that's exactly what's wrong with this program. And the only way to do it is to retype the whole thing right back in again. Because if it's a non-printing character, and I've had that happen, it produces a. It's
And it would be
interesting.
aided.
Compilers ought to be protected against non-printing characters, but very few of them
Whoever
are.
wrote the compiler ought to be.
Ought to be.
Kicked in the ass.
Yeah, but
With a decent word processing system to prepare this stuff,
You wouldn't have-
you'd find the that hidden character.
yeah.
You could do that.
Well, I've run across that in a couple of earlier programs, and I suspect that's exactly what the problem is here. If there's a non-printing character that you can't read from the,
This reminds me of Charlie's way of giving direction as far as writing a program. When he'd come into his office and he'd say, I'd like you to work on this, and this is essentially the direction I'd like you to take. And then he'd take the back of an envelope and he'd write about maybe anywhere from 6 to 8 just opcodes, 2-letter opcodes, and he'd say something like that. There we go, running off and try and translate what he was up to, but that was enough.
you mean he told you that was approximately right?
Yeah, and more often than not, that turned out to be the
I didn't like
kernel
to
of the
fill in the
code.
addresses.
He never put the addresses in. Always just a 2-letter string.
Because philosophically, it's very interesting to hear about a concept of an approximately correct program.
Do you know any other kind?
Well, it would take us another 3
you
weeks
have a point.
to finish it up.
Well, I really do miss
I think in the earlier days, at least in the the early 50s, Whirlwind had such a small memory and relatively low on auxiliary storage, even that there wasn't really time to think in terms of developing higher level languages. You were working on some things, but we really had a fairly small group trying to support a fairly large number of users.
That's right.
Well, quite apart from that,
And Fortran, after all, was supposed to be a multi-facility.
until you got a tremendously sophisticated compiler, you couldn't afford the storage for a higher level language.
That's right. In fact, I remember in the late 50s when we were enjoying 65K of memory up on the larger machines at Lincoln, that I really became disappointed with some of the programmers who were getting sloppy and were not tightening up their programs and wasting a lot of space and letting them run longer than they did.
When did you first realize you were wrong?
Well, the ironic thing about it is now that's coming around to haunt us. For example, a good text editor. Most of them are written in assembly language because, now with some of the better compilers you can, but up until just recently, we had to do the editor in assembly language and make it tight as hell in order to get a decent responsive editor.
Yeah, you need the speed. But it's interesting. I talk to my students now and tell them, how bad it was in the good old days when you had 128 registers or 32 toggle switch registers. And they just couldn't care less. What are you talking about? That's prehistoric.
Well, considering what you can pay, what you can buy in the way of
We've got a
memory.
megabyte. Why should we worry?
I could almost afford a personal megabyte if I.
For example, that story about the 257 words and
Yeah.
I told some programmers about that, maybe a year or two ago. I can remember them looking at me as if to say, what are you talking about? Couldn't understand that at all.
So what?
Right. Big deal.
Yeah.
I think it was fun.
Oh, yeah.
Yeah, it was fun. You had to do a lot of puzzling. And well, I think part of the reason for the I'm guessing, the non-development of higher level languages, if I were part of that, I wouldn't have wanted it, oddly enough. And I think you have to be in some kind of position where you're aware of the fact that you need a large population of programmers who are not going to be able to handle assembler.
Well, put yourself in
IBM was certainly in that position. I mean, if you're going to market these machines, you've got to expand your population of programmers by an enormous factor. And the only way to do that, probably, is a higher level language.
Put me on the other side of the fence as somebody who was trying to do something for a bunch of engineers that I knew were never going to, they're not going to be full-time programmers. They have a job to do. The calculation is sort of incidental to that job. It may be the key factor, but they can't afford to be professional programmers. And I think in those days, certainly, you had to be a professional programmer in order to master the intricacies of assembler, even though the machines were vastly simpler in those days.
Do you think there's any future for a learning assembler? And if so, how would you go about attracting people into it? Because at first it's scary.
Try to write a word processor in interpretive basic and you'll go back to assembler language like that. I've done it.
That's right. There is an art.
But there are some.
There is a necessary art, and it may continue. In that, if you were trying to make a computer do something very, very, very fast, then you are trying to eliminate cycles, and you want to have as tight a control over that as possible, and you certainly don't have that control with a compiler.
And I think you always will find applications that stress whatever machine you're working on.
Sounds like a law.
Yeah, I think it is. I think it is. I've
Law of computer stress.
seen them go from 1,000 words up to 16 or 32 megabytes, and you still saturate something.
How's Grosch's law behaving these days, by the way?
That's been repealed. I think. 6 years or something like that. The trouble is, there's still a lot of people who believe in it. I think.
Just for anyone who looks at this 15 years hence, what's Grosch's law?
What's Grosch's law?
Who's Grosch?
Yeah, who's Grosch?
Oh my!
Oh, Grosch is still around.
He
still as controversial
participated in
as
the
ever.
Whirlwind thing too. He sort of came as an elder statesman from
He
Columbia, didn't he? And
Well, he worked with the Watson Laboratory in Columbia early on, and claims to have been the only person twice fired by IBM. In that he was kicked out once and then later went back with them and was fired again.
Well, he's still being cantankerous with the IEEE.
Well, he was a stormy petrel right from the beginning. I'm not sure when he became a regular member of IBM's staff, but it was right after the war, at least. At the very earliest computer conferences, he was cantankerous. Even at the very first one, the AIEE, in the early part of 1947.
We need a concise statement of Grosch's law, and
I
I'm
was
not
going
sure I
to
can do that.
default to you.
well, it was.
Well, roughly speaking. You want to try?
Anybody?
No. Go ahead. Had to do with computing capacity as the.
Well, it says, roughly speaking, that the more you pay for a computer, the smaller will be the cost per operation per second.
That's close.
I think he had a more precise description of that curve.
It was a square, wasn't it?
Was it square?
I think
Something
so.
like that. And of course, nowadays, well, I tell some of my students that after all, they have these hand calculators. Why don't they timeshare them? I mean, it costs money. So if it costs money, what you ought to do is make sure that it's always busy. Right? And that means you have to sit there and you have to rent it out to all your classmates. And if Grosch's law really held, that's what would be happening with hand calculators.
I have
Clearly, there's a limit of expense below which Grosch's law is
I
nonsense.
have had a psychological problem of that kind with my TRS-80. Having managed a major installation and being, very much conscious of $1,500 an hour or CPU time or whatever, I really hate to get up and walk away from my machine and leave it turned on and
idle. Yeah, it's built into you.
Yeah, right. It's an ingrained. I am paying for the electricity for it, but that's it.
That's not a major problem. Yeah. But I do find, that sometimes when I argue with the computing center at the university, I find it very difficult to convince people that Grosch's law has been repealed. As a matter of fact, as recently as 3 years ago, it was officially expounded by those people.
Well, I think large computing centers are not necessarily on the way out, but they are
but they're not
carrying
the
on
universal solution.
with a momentum that was build on principles that were established 20 or 25 years ago and aren't necessarily true anymore.
Yeah. That's my experience too. I mean, we'll certainly have them, but there are other approaches now that are economically viable. So
I think you need a large computing center to handle the jobs you would never attack on the others.
Well, if you can talk about numerical weather prediction.
Yeah.
Well, incidentally, Whirlwind was used extensively for, well, I don't know how extensively, but there was numerical. I remember a debate. Wasn't there a debate between Wiener, who was the advocate of statistical estimation, naturally, of weather patterns, and then somebody else was working on a solution to a physical model. Mm-hmm. Wasn't that done on Whirlwind? I know Wiener was trying to, or some of the students were trying to invert 100 by 100 correlation matrices or something like that.
It may have been after I was there.
Maybe it was. I don't know if my memory is faulty, but I think
Doesn't ring a bell with me.
I think there was some kind of debate. Phillips. Is there Phillips who was working on weather?
Don't know.
Not here then. Yeah.
No, when it comes to weather in the early days, von Neumann was the one.
Yeah, and he was an advocate of the physical model.
I'm
I
sure.
think, rather than the statistical extrapolation,
I'm
and
sure.
Wiener was the statistical extrapolation man. And I think the physical people have won at this point.
Right.
Nobody pretends to predict it on the statistical.
The weather was one of von Neumann's hot buttons through the late 40s, 1948, 49. Mm-hmm. He and I shared offerings at the ACM. Well, not the ACM. It was the 1948 conference sponsored by the Institute of Numerical Analysis in Los Angeles. And he prognosticated weather prediction as a major application. I prognosticated the elimination of wind tunnels. And I got the headline in the Times.
Well, they're both coming.
They're both coming.
Both here to some
That's
extent.
right.
Yes, as a quick sideline, MIT's moving their information processing center to the site of the former wind tunnel. No use for the wind tunnel.
Is that right? Oh, it's interesting. When I was going to mention my early involvement with Whirlwind this morning, I was going to mention the wind tunnel. That's where Bicknell and I visited in 1943, and I was touring the institute before we gathered this morning and saw it for the first time in years and years and years. It gave me a nostalgic feeling.
Well, you've talked about the wind tunnel and weather and so on. And you had lots of applications in this, coming from all parts of MIT and outside of MIT in this area. Now, today, if we look at what computers are being used for, they're widely used in business, social science, economics, and so on, as well as in mathematical applications and engineering and process control. What did you find as you began to open up your facility to would-be users? Who came in the door? When did people begin to think about social sciences applications? Did you have to bring this to their attention, or did they come in rushing the minute the door was open? I mean, what was
Not that, sure.
not like that, I see. Well, how did this begin? How did you begin to see these non-engineering, non-mathematical applications coming in? Where did they come from? What stimulated them?
I don't remember many of them here.
The time I was at Whirlwind, there wasn't any. It was primarily the engineering and mathematical aspects.
I remember some really interesting quirks. We had a numerically controlled milling machine here, for example, and quite a number of people came to Whirlwind to essentially calculate the tapes that would control the numerically controlled milling machine. I remember one student that came in. I was consulting, I guess, on numerical solutions. He probably wanted to machine a turbine blade. And all he had was a blueprint, and it had all sorts of points. He plotted all sorts of points on his turbine blade. I don't know. And he knew about fitting with polynomials. So I don't know how many points there were in the upper part of the turbine blade, but let's say 50. So he actually passed a 50th degree polynomial through those points. And of course, and then what they do is they machine a wood turbine blade. You know, they want to waste the metal on practice. So we came in with this wooden turbine blade, and it was
Pretty ragged, eh?
really ragged. And I had to persuade him that you don't pass 50th degree polynomials through 50 points and expect a smooth fit. And so we evolved a scheme by which we used arcs of circles and, you know, blended them together with continuous first and maybe second derivatives, or first derivatives anyway. And that gave a reasonable turbine blade. But I remember also talking to a civil engineer who came in, and he had a formula for numerically solving a differential equation that came from a civil engineering book. And he said, well, how's this? Is this a good way to solve this problem? And I said, not really, because by using even a simpler formula, I can get one order of accuracy better than what you're going to get with that one. And he went away, and he came back a little while later. He says, if you don't mind, I'm going to use the one that I brought in, he said, because I understand that formula, and I don't understand the one you're talking about. Now, the issue here was probably a factor of 10 to 1 in computer time. And so I learned very early on that you're not going to talk people into economizing on computer time. What could I say? He said, I want to ask you only one question. Will that formula work? And I said, shh. Yes, it will work. It'll take you 10 times the machine time that you would otherwise take, but he had the source of funds or whatever.
Well, actually, that was one of the things that was going for us and against us was that the time that was available, at least while I was there, there was no charge. Basically, it was
free.
Anybody that
We had to negotiate with Charlie.
was interested in. We had to fit in with other people's schedules as far as, but in general, we weren't all that short of time, other than that we had to keep people off of the console in order to get them.
Well, unlike in modern days, you weren't paying anybody for the time yourself.
Yeah.
So there was
Well, the other point was,
See, and I didn't turn him
the
into
machine.
you, did I?
The machine time was not. Assuming that you were able to get enough time to do your job, since you didn't have to pay for it, it was only a matter of whether you could get it or not, and we didn't
Well, I'm
have a lot of
surprised you
pressure.
didn't have a problem of billing for power. I remember I visited I guess one of the last Sage installations out in Santa Monica, and this was 15 years ago, 10 years ago, sometime in that time frame, and I had been going through a struggle with our IBM 36075 about our $400 an hour machine cost. There were many people who thought it ought to be much less than that, and discovered that they had a $600 an hour power bill.
That's a lot of money.
in the early days, you didn't dare have your program run too long anyway, because the dielectric would get you.
But it's sort of interesting because on another occasion, I had a mechanical engineer approach me, and he said, I want to solve bending of beams. And how should I do that? And I said, well, it's a fourth order differential equation with boundary conditions. Why don't you just solve the fourth order equation? And he said, I don't know anything about fourth order equations. I know about bending moment diagrams. Did you all learn bending moment diagrams if you were engineers?
Not very well.
You have these graphical methods of calculating the deflection of a beam under a load. And he said, well, can you write a program that would implement the bending moment diagrams? And I said, oh, that program would be awfully hard to write. And it's so simple to write a solution for the fourth order differential equation. He went home. He came back a week later and he says, I want you to tell me how to write a program that will solve bending moment diagrams. And you see, the method that was manually attractive turned out to be really a very difficult program. And if he'd solved the fourth order differential equation, he could have arbitrary loadings. Otherwise you had to have piecewise linear loadings or something like that and draw the graphs. And, I learned something about that, and it was that I didn't want to spend my career counseling people who were going to solve problems on digital computers. I really seriously, consciously came to that conclusion. I didn't want to do that for a living. I mean, it was futile.
In the Redmond Smith book, Appendix B, you probably remember, is a memo by Bob Everett from 1952 about the Whirlwind computer, and in there he's got a partial list of the actual problems carried out by the group, and then he lists, the first one he lists is selected, I guess, precisely because it isn't a typical engineering problem, an industrial production problem for the Harvard Economics School. I don't know if you remember that one at all, any of you. But then it goes on, the others are all engineering to some degree at least. Magnetic flux density for our magnetic storage work, that clearly is. Oil reservoir depletion studies.
That was Jack Tortoise.
Yeah. And that presumably was purely physical and not economic, I would assume. Or was it also economic?
Actually, that was being funded by oil companies. They were trying to figure out how fast to pump oil out so that they could pull oil out of the, what do you call it, the auxiliary cavities. And if you pulled it out too fast, it'd collapse and you'd lose that much oil. If you pumped it too slow, you got all the oil, but it was too expensive. And they were trying to find the most optimized pumping speed. Wasn't that, do you remember that problem?
Yeah, basically.
But I think that was about it.
So that was an economic problem, too.
Yeah.
Yeah. Mm-hmm. And then ultra-high frequency television channel allocation investigation for Dumont.
That was John Kembelik's.
Bob Wakeman from Dumont came up and did that himself.
Why do I keep thinking Kembelik was involved?
Yeah, I've been vaguely involved with that. That was a combinatorial problem of trying to using the distance. When the FCC was going to allocate UHF channels, they put out a statement that you could not have channels that were separated by channels that were off by. There were rules due to harmonics as to the channel and its next channel number. The second channel, the sixth and the seventh, or something. All had to be certain minimum separations, and the idea was to take a physical map of towns where you might like to have UHF channels and see how many channels you could allocate. And the program that was ultimately set up was essentially kind of an exhaustive search, and was never really. I don't think successfully completed. We ran stuff. He ran stuff and went home with it. But they never got around to allocating that many channels, and never wanted them ever since. I don't think.
There's a side story on this. He brought his 12-year-old, I think it was a 12-year-old son, in. It might have even been. He might have been even younger, but we were there on a Sunday, if I remember, and Charlie was walking him around, and I was given the job of entertaining the youngster, which I thought was going to be a very boring thing. And at the end of about an hour and a half, I was mentally exhausted because it turned out the kid was a genius. And he picked up everything about Whirlwind and so forth, just like that. I often wondered what happened to that young fellow. Do you remember the boy?
Bob claimed that his son invented logarithms independently.
I think it goes on with optical constants of thin metal films. That's a regular engineering problem. Computation of autocorrelation coefficients. Is that what you were talking before when you talk about these 100 by 100 correlation matrices, or is that something else?
Well, this would be an autocorrelation, so it would probably be a smoothing problem, a prediction problem.
Wiener stamp.
Yeah, it has the Wiener stamp on it.
But I don't know who did it.
But he probably didn't do it. But
No.
And then tape generation for a digitally controlled milling machine is the
That
last
was-
one on this list.
That was,
Doug Ross was involved in it. Also, like Carter Oil was up here doing seismic, trying to analyze seismic exploration data. The seismic techniques were just getting started, and but again, they were kind of trying to break ground, and I don't know they ever produced anything too useful from Whirlwind except to get some experience with it.
Let me make some remarks that might help on this issue of the application
Yes.
backlog, if you will, waiting the digital computers.
Yes.
I was going to mention something along these lines this morning in connection with comp centers. And to emphasize that long before the electronic computer came on the scene, computation centers were well known. Perhaps the granddaddy of them would be the astronomical calculation bureaus, which go back a long time. And then the military proving grounds, like Aberdeen and Dahlgren, had a long tradition of dust calculation and ballistic calculation. And there was the astronomical computation center that started out in the very late 20s at Columbia, the one that Herb Grosch was associated with, and where Tom Watson Sr. fitted out Wallace Eckert with specially adapted machines for astronomical calculations. And Wallace Eckert published a book in the mid-30s on the application of punch cards to scientific computing. And there were the IBM service bureaus, which, and all of these constituted comp centers handling a pretty well-defined backlog of problems, ranging from insurance and statistical problems on through the astronomical. And then here at MIT, there was the tradition of the comp center represented by the differential analyzer. And by the time I arrived on the scene, it had dealt with over 100 problems, probably 125, 130 problems, representing a broad spectrum of applications. Not all of them successfully handled, but some of them quite successfully handled. And the comp center, the Center of Analysis, when it got underway, brought in the simultaneous equation machine, and apropos of your inquiry about social science calculations, one of its principal customers was Leontiev.
Yes.
Going back to a very early period. And he remained a customer on through the war. So there was a well-established family of problems that were typically being handled on desk calculators or with these new machines that came on. So when the digital computers were in prospect, it was fairly straightforward to just, in effect, extrapolate their broad application to the full spectrum of problems already dealt with, more or less successfully.
Thank you.
Right here at MIT, optical calculations in the physics department. A well-known task that shouldn't be done that way. I was involved in that myself. Using a desk calculator to do ray tracing.
Oh, yes.
Yeah.
Yes.
Wasn't Jerry Mahoney? Was Jerry Mahoney around here? Interested in?
There's some people over from that did
Optical ray tracing. Oh, I think I've got the wrong guy. But that was done here, wasn't it?
Well, there were several different people who did various. I mean, somebody tried to design a new planetarium system using. I mean, do the lens design.
And it seems to.
Planetarium and Retina Foundation is in our movie as being lens design.
I'd be remiss to not include Stark in that recital of customers of comp centers. He was the heaviest user of the Rockefeller differential analyzer.
We ran that for 2 or 3 years, and it was
That's right.
with Frank Frizzou.
Right.
Interesting anecdote there. The problem that we were doing predominantly there was lead pursuit flight aircraft
Right.
for fire control systems. And the first serious problem we ever tried to code for the algebraic compiler was a three-dimensional full lead pursuit course, which was just too big for the 24 integrators that the RDA had. We I think spent about an hour and a half coding the problem, of which about 3/4 of an hour was spent in trying to decide on notation. Even in those days, mnemonics meant something or other. We coded it with the usual beginner's luck. It ran correctly the first time.
Not bad.
Very impressive to us, and much more so to those who were disbelievers.
I had a pleasant visit with Bob Siemens a couple of years ago, who was Stark's chief representative on the work, and we reminisced fondly about the period.
Well, we see Bob quite a bit because he's on our board.
You know, something of this sort probably ought to be done for the Project Mac. I assume it probably will be.
I'm sure it will be. The pressure is on for the earlier projects before their survivor.
Oh, before the survivors disappear.
They're coming chronologically, right?
I wish he hadn't said that quite so explicitly.
Well, I had a fascinating experience last year exploring the possibility of having an observation of the 35th anniversary of the birth of the industry. And I was originally fired up about it, letting 47 mark the beginning, when, among other things, Jay organized his IRE conference session in New York. And the upshot of the proposal, one of the upshots of the proposal was the proposal that I get together with the survivors of 1947 conferences. And the survival rate was about 50%. And,
It's a tough profession.
But it's probably of a higher rate than many, because there were a lot of young people getting into it.
that's correct. That's correct.
Well, that is true. You know, I have observed that
Was
I am always the oldest. And the reason is that there weren't many in those days.
Yeah,
it moved pretty fast, and young. It was a field that young people could become fairly senior in rather quickly.
Rather quickly,
Well, the other thing that I always found beautiful about it, phonies couldn't survive very long in a situation where the code had to run. And,
Or not.
it was a question of either writing a decent program and doing it well, or being exposed
That's right.
pretty quickly. I think it's also worthwhile maybe to discuss some of our experiences with regard to what made good programmers and why some very talented people were klutzes at it, and still are, I guess, still happening. I can remember the various people coming over from the Institute that were going to try and solve their problems, and some of them were literally incapable of understanding how that machine ran, even though they were going up for a PhD in something, whereas others just understood the concept and would turn in beautiful programs with very few bugs and would run them. And it's kind of amazing why people differ so greatly and still have good high IQs and are good scientists and well-educated people.
Well, it's part of a larger question in my mind. That is the question: how is it that programming is the only field where you can have orders of magnitude difference in the performance of the practitioners?
in fact, it's not hard to find situations. I can name several. One in particular, when we went on to the second stage implementation of just not to do with Whirlwind, but more recently of the Instanet system, and put it onto a DDP-11. We organized a group of about 10 people that we hired out of a large number of interviews, and put them to work on developing this thing, and it was going nowhere, and we finally found a very bright guy who was working on a similar sort of project in England, imported him, got rid of all 10, and he wrote the whole program.
Oh, no.
And it was a system that was pretty elaborate, but not quite too big for one person to handle.
That's fascinating.
And if one person understands what he's doing and can handle it, it runs an awful lot more smoothly than, and 10 people were just literally making almost no progress. And with one guy, of course, if anything ever happens to him, I don't know what the project will do.
It's so true. Over the many years, the difference between the so-called mediocre programming talent and the very extremely good talent are literally in the orders of magnitude. I mean, there's some people that are giants as far as productivity, logic, intuitive ways to make the machine go faster and so on. And happy is the computer manufacturer who has a good core of those babies in the middle of his engineering department.
That's right.
Well, is Wiener's prediction going to come true? I ask that because just in the last week or so, I've had a couple of experiences that indicate as I was mentioning at lunch, a polarization between high-tech people and what has been called liberal arts people. At least those are the terms in which this polarization is occurring. Within the University at Albany, and even our governor recently said that he liked very much to support high-tech education in the state of New York, but not at the expense of liberal arts. That statement seems to be a little gratuitous, on the surface of it, but I've heard something like that from a surprisingly wide array of sources. Maybe being in an engineering area like MIT, one doesn't find it because there's no hope for the opposition, perhaps. But if you're in a university that does not have an engineering school, then the shoe is sort of on the other foot, and one actually becomes kind of isolated, or at least you have a feeling of isolation and almost apologetic about being identified as high-tech. And I kind of wonder if something isn't going to happen to our society with the continued evolution of... we certainly require a larger and larger number of people to write programs, and we know theoretically that automatic programming is, in its pure sense, is an undecidable problem, although in other senses it will certainly be done. That means a need for a large number of people. And is it going to be true that jobs are going to be available primarily for, as Wiener put it, electrical engineers and mathematicians, and that other people are going to have to be satisfied with a lower level of work? Is that a consequence of the machine age?
Well, I don't think that it's fair to think that the only worthwhile jobs are going to be high-tech
It's certainly not true, yeah.
But the thing I see in the area of office automation, for example, bringing sophisticated power tools into the office and so forth, I see the businessman being able to use the computer in extremely sophisticated ways, which means that they're going to be able to run their businesses that much more effectively. They'll probably need fewer people, particularly in the middle management end of things.
So that's been documented.
All right, and
the reduction in middle management personnel.
I still think that the guy that's leading that company or the key people in it may be performing certain things that are extremely high-tech oriented. I mean, they're modeling and so forth. They'll just assume it's, they'll know how to feed it and so forth. They won't necessarily have designed it. But they also will be part of this higher aristocracy of people that are running the businesses of this world. I worry about that middle management crowd, and are we going to ultimately wind up with a group of people that have to be well-fed and give them a good supply of video games so that they don't revolt, while the smaller percentage go off and do the high-tech stuff and use the more sophisticated power tools to run the businesses and so forth.
It's certainly clear that the existing unemployment rate is to some extent a technological displacement.
No, that's right.
I'll bet people will look back at 10% as though we're great. I know, 10% unemployment is being super
Super low.
when they start looking at 20 and 22%.
Well, that of course means that the productivity of the people engaged in that activity is going to have to be pretty high.
Giants, very similar to the programming thing.
Yeah.
You give the right kind of tools to a very capable guy in business, and he will, just like a
See, Charlie's
programmer, will be able to do tremendous things with it.
one employee is what, being productive enough to support the
Knocking out 10 programmers for all practical purposes.
that you just got rid of.
Unfortunately, people don't necessarily pay a proportion.
Yeah, right.
Unless you get yourself into a profit sharing arrangement or something like that.
Yeah, but I'm thinking of the overall economic picture. And,
Though Norbert Wiener discussed things like that back in 1947, 48. Did you think that way in those days? 1950?
One of my favorite slides that I used to use to dramatize things was a Boston Herald issue that had really banner 4-inch headlines. Thinking machine seen replacing man, it said on 2 lines of 4-inch type, and a big picture of Norbert Wiener in the middle underneath. He'd made some utterance, and it really grabbed the Herald that day. I guess they didn't have anything else.
yeah, but for many years this wasn't apparent,
That's
except in
right.
Wiener's observation. But now all of a sudden it becomes a little bit frightening because we see things that.
I think people were a little frightened reading it in the paper that day, too. It looked like it was just around the corner, and then when they realized things were not changing very fast, and now it is catching up with it. I mean, after all, that was 35 years ago. That's right now.
Well, the whole business of robots is roughly 35 years late.
Yeah.
On arriving on the schedule that Wiener, in a sense, foresaw. You remember John Hudson?
Oh, sure.
He was touting robotics and robotronics in 1946.
Well, it's taken a while.
I was always impressed by the guys that wrote the comics in the 30s. They, I think, had their own R&D development group or something. They called so many shots it isn't even funny. The wristwatch radio and the rockets and so on.
He is an educator. One concerns oneself about how one prevents this, at least for the students that you have.
That's right.
What measures can one take to make sure, or try to ensure, that they are in the affluent bracket? And I'm not sure I know.
Well, it seemed to me when I came to MIT as a freshman, a lot of courses were at that time being taught, how you had steam tables and you had handbooks and such things, and gradually, by the time I was graduating, even things were moving. The electrical engineering department was giving up handbooks and becoming essentially a physics department, and it is adapting to teaching people how to think rather than how to do specific things that schools have to do.
That's right.
MIT certainly moved ahead with that fairly early from some points of view.
That's right.
Well, but doesn't being associated with MIT put us in a position where it's rather difficult to have a good perspective on this issue?
I think it does.
Yes.
I think it
Yeah, the
does.
answer is
No,
yes.
no question about it.
Right, so it's the individual that majors in basket weaving and then wonders why he's not getting a decent job in a area that is going to be so competitive.
See, I'm teaching in a public state university, and I think one gets a different perspective on the problem. Certainly, I had no such perspective when I was here. I mean, you look around you, and everybody you see is okay. You see, but then when you go out there and you look at a somewhat broader population, the problem really comes home. So maybe. All that pioneering effort at Whirlwind is going to create a social problem that is going to be difficult to solve.
Getting a little far afield.
I think you really covered the subjects without us asking the questions. You did a very good job. if there's anything you want to say as a final set of remarks, or you think you've said your final set of remarks, you can.
Well, I would only like to reiterate what Peg Odden said at lunch, and that was that the environment at Whirlwind in those days was magnificent. The morale was so high, and the enthusiasm was always exciting, and it was an extremely wonderful time in my life, and I suspect it was in everyone else's here.
I've often thought this way, that there are probably very, very few, if any, Whirlwind people who wouldn't count their Whirlwind experience as one of the high points of their life.
Yeah, very, very beneficial. It's remarkable, a little humiliating to somebody who's a college professor, how much education you can get, say, just from that environment, independent of any formal classroom work.
That's right.
Bearing that in mind always increases my humility a little bit when I stand up in front of a classroom.
I got to say, I think that's been Draper's philosophy for 50 years.
No, that's right.
Draper has been an outstanding expert.
No, that's right. But it brings to my mind a story in connection with this book. I accepted a request to write a review of this for Computer Reviews, and I've got to make good. Oh my goodness! And there are a number of reasons, but one is this. When I accepted it, made the commitment, there was just a presupposition for me that these two things were true. That on the one hand, Louis de Flores, when he came to Hunsaker originally, had an experience with a Martin flying boat, for which the training simulator was being built by Bell Labs. And when the simulator was set up in accordance with the aerodynamic data that came from Martin, it was unstable. And they struggled with their computer, thinking it was an error. And it turned out that the aircraft was unstable. And I personally am certain that Louis did have this experience, that he did tell about it in my association with him. But it's completely unknown to the authors of this book, and nobody in Special Devices will verify it either, that I've been able to track down. So that slowed me down. But when I do write the review, I'm going to say, even if it's apocryphal, it's still
That reminds me that one of the most important social roles of the computer hasn't been discussed here, and that is the role of scapegoat.
Haven't seen a computer yet. I couldn't learn to hate.
And I mentioned two things that I had in mind. The other is this, that I am certain that when I first sat down with the two authors in roughly 1965, after they had gotten their commission from MITRE to do the book, that they explained to me that the MITRE people, particularly Bob Everett, were anxious to inquire into the factors that made Whirlwind the unique human environment it was, in the experience of everybody who had been there. And I said, well, that's great. It's another good reason for this book, and something that's borne out in the review. But the two authors insist they never told me that.
I was disappointed in the book from a software point of view. I felt that they touched on that only lightly.
They did.
I think what is tremendously missing is Charlie's group's contribution. It's addressed only in a very offhandish way as far as I'm concerned. I think a lot was done in his group that ought to have been recorded.
You're correct. And there is the long list of Whirlwind firsts that was featured at the Smithsonian meeting when the Whirlwind exhibit was opened. And that list, even if some of the items are controversial, should be brought forth in a prominent fashion.
Well, I for one have enjoyed seeing all of you people again.
Well, it's been a great pleasure for me, I'm sure.
Privilege to be amongst this honored company.
I think my wife found it was a very nice excuse to come back and
You're right.
I couldn't have stayed home.
That's good.
Thank you.
Good.
We have some releases for you to sign. I don't know if that was part of it or not.
What's this one? Yeah, you arrived?
Oh, yes, they've been here all along. We just pushed the button, they came right off the Xerox side.
Oh.
You know where they are?
I do.
Okay.
They're under a coat or something back under the camera.
Nice to see you again.
Yeah.
Broken up at the time, it's probably obvious.
It has, if you'll describe, really, it's. I
was in the other room for the last
say so.
few minutes.
Picking up some problems there, yes.
Probably only have to do it
Thank you
once.
very much. Thank you for inviting me. It was very much of a pleasure.
Oh, yes, I forgot that.
Okay, I just mentioned that.
Yes, that's right.
If you want a copy. Oh, that went fairly well.
Oh, I think that was marvelous. Absolutely superb.
We've not touched much on software before. In fact, hardly anybody has, as you said before. And about time we get much more into that.
I have to take back one of the things I said at the beginning. I said, you're not movie stars.
Very generous.
You want to?
I'll hold on to those if you want.
Now, I was thinking of going out to Marlboro if we wanted to. I'm sure we can get you a ride back to Boston.
Well, I did rent a car. No problem.
We have a car, so that's a possibility.
However you want to do it. I mean, what time will this Marlboro thing be over?
Well, if it starts at 5, is this the usual lecture or is this some special?
Well, I think there's a dinner afterwards.
Well, there's a lecture, I think, usually runs 5 till 6 or
Yeah.
so, then they have wine and cheese afterwards for
Right.
anybody who wants, and then at 8 o'clock, there's some people going out to dinner.
Yeah, I probably won't take Wednesday for that.
The dinner thing may be on a pre-reservation basis, and then.
Is this a pioneer lecture in one of the series?
Yes.
I'm surprised we didn't get a notice, but I've been getting the notice.
They
every
sent out,
day.
they did, at least they
It
had
came out.
poster type things
Yeah.
that they sent out.
I'll probably get it
May
tomorrow.
get it tomorrow. It came out several weeks ago, I got a copy of it.
Thank you. Well,
Very talkative and interesting in the
Yeah.
software field. Morris Wilkes did one a number
Yes.
of months ago, and Herb Grosch was there the time before.
Right.
Before I forget.
Were you planning to go?
no, I unfortunately don't think I could, but I would be. I mean, you have a choice of alternatives now, and it's up to you what you want to do.
I hate to admit it, but my computer's been down for a day, and so I'm going to get back to work.
All right. Imagine that.
Still, the RPO 7 was on the fit, so we've got a lot of backlog here.
I'll get to talk to you sometime.
Come in.
The word processing division.
This is a class of mine that just started and was looking at you for a few minutes in the other room. So,
Can you tell me where this hotel is?
you haven't been to the hotel, you haven't
No.
registered? Okay.
No, but I thought maybe
It's,
I-
it's in the
Nearby?
Commander, isn't it? Or is
No,
it
I
somewhere
thought it
else?
was the
No,
Sinesta.
Sinesta.
Oh, you're in the
Right
Sinesta?
down.
Okay. The Sinesta, when you go out onto Memorial Drive, you go left, east.
Unfortunately, I don't think
Okay.
we have time.
Okay. And just before you get to where the Science Museum is, just before the dam across the river,
Do you want to get together all before this?
there is a hotel
Wing it,
overlooking
so
the
to
river,
speak.
that's the Sinesta.
I don't know,
It's very
probably would be worthwhile.
Yeah, yeah, yeah. Okay. And you have transportation?
No, my wife has a car, but that's
Yeah,
all
since
right.
you're up in New
I mean,
Hampshire,
just
we
walk
could-
over there.
Maybe we could.
It's a good little walk if you're a
I'm
good
a
walker.
confirmed jogger.
Okay.
I'm not jogging today, so
All right.
I should do penance in some parts.
Sheraton Tower?
Yeah.
Excuse me, I think I will not go to Marlboro.
Yeah, that's
All right, well then
That's a nice place to have.
where are you staying?
Mine is, after the discussion today.
I pick you up there then
What we
at,
got. Might just set up.
6 o'clock.
Things.
Okay.
Very good.
And just bring it.
Very good. Will you join us?
My wife
With
has
some vague outline, because otherwise it'll be pretty boring.
an old
I was thinking of trying to get them show that.
Your plans are,
Walk back, unfortunately, you have to so early, you'll have to show
Or
it back.
pictures.
have you talked to Jerry
Then
Rogers?
go, then have dinner with the whole flame.
Oh,
Married 40 years ago.
do it.
All right, so you're not joining us.
No,
She was thinking of doing it up on the
Very good.
balcony where the Whirlwind.
Well, let me
exhibit
say thank
is
you
located.
to each of
And I said, well,
Oh,
if we're gonna show anything on the screen, it may be necessary to do it down in
and I'll see you later.
very good area.
It was a pleasure to
And I
meet
think
you.
that's probably the best place if you're gonna show the film.
Because when I say film, I actually showed it videotape, so I don't know.
Reading outstanding job of keeping us moving.
Well, thank you very much. Pleasure to
You know what else would be
see you
kind of fun
again.
if
Let's
they could show that
assume that
down,
we
see
did
how
meet
they're
years
really-
ago.
I think we may as well use this couch, this sort of this set as our classroom.
No, I mentioned that to them too. They had.
Well, you and I were quite close.
So just make yourselves comfortable.
Do you find MIT a good place to study the history of science?
Oh, yeah.
You wanna pick up
You and I came here at the same time, 53.
Oh, is that right?
Yeah, that was when I arrived also, but it took me a long time to discover what you were doing. Yes. So I've been here quite a while, I do enjoy it, yes.
Today's the 14th. Do you want to do it the week before?
also have the grapes.
So I did a little bit ahead in case there's any preparation that needs to be done, although I don't.
Bring the cookies over too.
We should have kids at expectations together earlier. Really do much for it.
It's hard to tell because I never really.
Well.
Well, you know,
Come back to
2
this
nights,
in a little while, let's talk for a moment about.
the 25th and 26th.
Incidentally, Tuesday is second day of Patriots Day, as you know, so the next class is a week from today.
Do you want to do the 21st
The
and
usual place.
this weekend we have to do,
So we don't need complete lights, Suzanne, if you could find the switch.
why don't we meet at 6 o'clock?
Where's the switch?
Last time, we were talking about the airline
With these lights.
systems again. There's an interesting evolution. That's more comfortable as a couple. An interesting evolution, which is not just the airlines, but it's fairly characteristic.
It's cheaper to print on the zero.
See, this started with the
computer.
described it, with each airline building
That's
its
why
own
they bought a
system.
second one.
Yeah, my guess
Weren't
is
here
that
when we talked about the safer system
Instead of time
that
sharing
we
going
talked about
down,
last
go over
time,
and
that came
outline,
up in today's
going
discussion,
up and
because that came out of
Mark it up and.
Sage, which came out of Whirlwind. So it was all part of it.
I'll see you.
Each airline built its own system.
See you at the
It
registration
became
desk.
advantageous to link this. They had to agree on certain standards
My relationship.
in order to be able to link. And in addition,
Score that I didn't think I was going to say.
interconnected lines so that they could
I'm just